Hi, everybody. Welcome back to track 4 and Agents in Production. We've got a really great talk coming up from Shaun, who is going to talk about some of their work in healthcare and the call center. So Shaun, I'll turn it over to you. You've got about 20 minutes here for your presentation. I'll come back and give you a little bit of a time check towards the end of that, and then we'll have 5 minutes of Q&A from the audience. So Shaun, take it away.
Okay, thank you, Andrew. Hello, everyone. This is Shaun, and I'm the CEO of HeyRevia. So today I'm going to talk about create an AI call center agent for healthcare. And thanks for inviting me to the AI agent in production. Hopefully you have learned a lot, and let's get started. A little bit about me. I have been building AI for the last decade. I started my career in Google building Google Assistant. If you remember, back in 2018, there was AI calling restaurants and hair salon on your behalf. That's part of Google Assistant. After Google, I joined Pony.ai building self-driving cars and building on how the autonomous vehicles works and how the autonomous agents works in production. Then I built an open source voice agent project with 6,000 GitHub stars. And personally, is a AGI believer, and you can follow me on the AGI Shaun. As for today's topic, we're going to cover why we should have AI call agents for healthcare and how the voice agent landscape has been shifted for the last couple one years. And I'm going to introduce how HeyRevia works and some of the real world use cases how Revia is handled right now for our providers and patients. First, why AI call agents for healthcare? If you don't know, that's more than 30% of operations for the healthcare are running on phone calls. Those phone calls can include very simple calls like your appointments and the check-ins. But for the provider part, that's more complex. It including they need to work with insurance companies, work with you to handle things like credentialings, help them to get in the internet network, and also handle claims if some of your insurance get denied, and they have to handle those to negotiate with the insurance companies. Also, before even you go to the AD clinics, they also responsible for check the authorization of prior auth your insurance before, so your insurance can pay your visits. So that's why the whole healthcare infrastructure is running on the phone calls, and all those phone calls are really tedious and can repeat itself so many times a day. So what is the current solution? If you own a clinic, or if you provide professional business solutions for healthcare industry, you pretty much work with BPOs and call centers all the time. And so what it actually happens is two sides of the business in the healthcare. Like if you are clinics, or if you are professional business providers, or if you're an insurance company, you pretty much hire agents in call centers talk to each other. Sometimes they may just sit next to each other, but they have to go through phone calls to talk to them. Somehow there's no better way to handle those just through all the phone calls. And all those phone calls are really, I think, really repeat itself. So this is when we check all the healthcare, we find there should be a better solution for all the call center agents. And the AI agent already has been really good at talking to humans and understanding the scopes. So that's why we started to build the HeyRevia to replace all the AI call agents in those call centers. So let's talk about all the voice agent landscape. Why people are excited about the voice agent, and what are the new things you can build with the newer tools? So one thing you have noticed in the last 2 years, all the speech to text and text to speech has been getting so good, and with larger model itself can understand, start with all the text, then with all the voice audio input directly. if you have seen all the newer OpenAI real-time API, you realize they can communicate really fluent in voice conversations. But then you get the question of, with all those like audio input and audio output, how do you actually control the voice agent in production? So on the right is the simple graph with all the pipeline-based voice agent platforms. Those platforms, including the popular solutions like Vapi, Retail, Blend, they all build on top of this solution, like in the graph on the right. So start from like the very bottom of the Twilios on the bottom, or like 10x. Then you have the streaming input you have to handle with WebSocket and WebRTC. Then you have all the speech-to-text ASRs, like assemblies, deepgrams, whispers. Those solutions help you to convert audios into actual text. With all the text-based larger models, those text will be understand in the larger model right now is not working with your text streams. They're working with text chunks, meaning you have to make sure you have the correct text, or when the sentence finishes, you send those text into the larger model. Once you get the text out, you use the text to speech to generate all the audios back. For a voice agent, that's how it works. It goes through the same pipelines from the telephony systems all the way to the text-to-speech. So what are the limitations, you may ask? For all the voice agent, you have to control all the audio bytes input and audio bytes output, everything in between. Meaning, if there's certain things like get latency delayed, for example, if Twilio is down, your system is crashed. There's no system, then there's no phone calls can be generated. The problem with those is, with all the voice agent, you have to control every little bit of information. Twilio gives you information in every 20 milliseconds. If your system is not performant enough and get delayed for 100 milliseconds, your user or the other side are going to notice there is significant delay. That's why a lot of systems built on top of the pipelines really suffer from short latency. Like if the latency is going beyond 500 milliseconds, the other side is going to notice. With that, also like common issues with larger model, there's hallucination problems. When you, especially in healthcare, that's really hard. For example, if you are working with a pharmaceutical companies, if you're trying to tell the other side, tell the receiver and saying something about your prescriptions, if you get the millisecond wrong, or if you get the volume wrong of them for the medicine, it might kill someone. So that's why for hallucination problems in healthcare is really critical, or it's sometimes even deadly. Also, like for voice agent, if you know to have a natural conversation with a human for 10 minutes, make sure the voice agent also complete the task you want to ask it to do. It's extremely hard. So what the voice agent have to do is, like, you have to keep retry the same cause sometimes. If something like really the voice agent is really confused, you're going to have issues with the agent talking to a random result. Then on the other side, you have human callers. If you're working with human callers, they can only making one call at a time. They are very limited with all the information you share with them. If they have the big trend, then they can start to make those phone calls. So that's where the HeyRevia comes in. HeyRevia, like how we do is, like, we're trying to put all the AI agents into the AI call centers, and it's a fraction cost of how the human cost, and already add better human latency, accuracy. How did we do that? We started with building an agent like a human, think like a human. A lot of agents are building on top of like the pipelines, but for us, our agent is in the phone calls and trying to communicate with, trying to understand the context through like live input. our AI actually understands all the IVRs. So how it works is like it understands why you're making the call. It's trying to understand like what are the menu items when it's listening into those phone calls. Then trying to decide, okay, should I take a press buttons, or if it's music playing, should I wait and hold for a human to enter the call? It's all through the similar parallel pipeline. Once the human enters the call, it first trying to understand is talking to a human. Then it starts to, based on the objective you have set to the agent, it will try to negotiate on your behalf with the human agent. For us, like handling 30 minutes phone calls is pretty simple. The reason being is like our AI is working as a human. A lot of things like for voice agents you run into is like you don't get to control what's happening in the phone call. But since we process all the information in real time and we make AI agent like a human, you can actually jump into the call, like take over the phone call, saying, okay, the AI, you just like sit in the back seat. I'm going to take over the phone call and talk to the human directly. Then you just continue the conversation for me after I just like give you back to the control. Then the question is, how does it work on the thing? If you have seen all the voice pipelines, it's like every step you have to like have a separate component for it. But for HeyRevia, this part is really highly inspired by how the self-driving car works. When we say like it understands all the information in real time, there's a perception layer. It's trying to understand all the audio bytes and all the information we have passing to the phone call. It including if it's music playing, if it's already talking to a human, or if it's talking to a IVR system, it knows those information in the perception. Then it's trying to predict what's the right behavior HeyRevia should behave. A very common issue a lot of human encounter is if you are putting on hold for 30 minutes, there's nothing you can do, right? You just waste your time there. But for HeyRevia, it knows it's talking to it knows it's wait and hold. What it internally does is once it knows it's wait and hold, it's going to pause all the processing powers or all the larger powers for that phone call. It's just like going to sit silently and wait for the human to get into the phone call. It's going to save you a ton of token just by predicting, okay, we should be wait and hold for the human to enter the call. Then the next part is the planning. If you listen to the previous talk, a lot of speakers talking about like why voice agents is different than human right now. I think primarily because of the planning aspect. For humans, we know when you're making calls, there are certain steps you have to do. Or if you even know like, okay, a few things ahead of you, you have to talk to the other side before you can complete the task. But if you only use larger model as a whole prompt, there's no way you can give the information to the AI to ask it to do the right thing at the right time. But given the planning layer, it is able to try to think ahead of its time, think ahead of all the information it has, and trying to predict, okay, what's the next few things. If something is wrong, it's also able to crack the course of how it processes the phone call. The last bit is control, right? A lot of things, if the AI is starting to hallucinate, if it's like starting to get off track, that's where the control comes in. It creates a simple guide rail for the AI to make sure it's stick to the main objective we're trying to say. For example, if we are working with pharmaceutical companies, you don't want the AI talking about like your meals or lunch, those things. So that's where the control comes in. So then you're going to ask like, okay, this sounds great, Shaun. And what about how do you know if the AI is really outperform human? So our philosophy is like, if you're trying to ask AI agent to do the similar human work, you have to evaluate it like a human. So you can see how the graph works is we benchmark how human and AI works for the similar scenarios. We understand all the transcripts. We understand all the things when human side and on AI side. We try to compare them like against each other, how human performs and how AI performs. You can see here, based on our data, like our AI is already outperform human in a lot of those scenarios. Next, so the Revia now is like a standalone AI agent as itself. It's like a human, right? So you're going to ask like, what's the right way to work with a newer generation of voice agent that can perform on your behalf? There are two type of interactions we work with Revia. One is through our call center API, meaning when we work with Revia, we care about the work Revia generates for us. So we have something called work API. You can submit those call works to Revia. If Revia itself, like when during the phone call, is hallucinate and fails that phone call, it knows the right way to collect the information from you. For example, when we help with providers to call insurers, if the provider ID or the NPI number is wrong, Revia identify those issues during the phone call. It's going to ask you those information either live or complete the phone call. Going to ask you the information before you try to retry call the insurer back with the information. It's all by like work API itself. The Revia is able to identify its own issues and learn from its mistakes and continue to call them on your behalf. That's what we call as call center API. If you want to have more control over Revia yourself, we also have a call center UI, meaning you can see we are making like 10 or 15 calls at the same time for Revia. And you can jump in any individual calls, just like when you supervise a call center. You can jump into any individual phone calls and try to, if you spot any issues, you can take over the phone call and talk to the human from the other side. That's the call center UI. So some of the real-world examples. So, for a 30-minute phone calls, especially for in the healthcare, it's really like the what I paste here. You go through the IVR system, trying to understand what's the right way to get to human. Then you're going to provide a lot of repeated information about NPI, member ID, bunch of things. Then you're going to wait and hold for them to come in. The last is going to negotiate with the human for the information you need. The remaining is like, okay, once everything you need, then you start to handle the phone call. A lot of things like for healthcare are the credentialings, prior auth, like prior auth and the referrals and consultings and billing inquiries. Those are the things like really important for healthcare. It takes a lot of time for them to complete. But with Revia, we are able to handle pretty much like 99% of those cases at a really high accuracy. So I have a quick demo here, but it's also in the HeyRevia website. I think we may not have enough time to go through all the examples. Yes, I'm going to have give the time to Q&A if you have any questions.
Yes, thank you so much, Shaun. Really, really interesting work that you're doing in the healthcare space there, and really great to sort of get a sense of the architecture, sort of the ability for the humans, like the management to step into each of the calls and to provide that level of accountability. It's really quite interesting. We do have a couple of questions here in the Q&A, and one that I wanted to ask first is, again, on this theme of working in healthcare and regulated industry, there's a question here around, are there any sort of particular scaling challenges in your agents or in your agent frameworks or maybe in your testing that might be unique to healthcare or to being under regulation like that you might not run into if you're sort of in a different industry?
Yes. So I think in healthcare, the question you're going to get asked a lot is like all the compliance you have and how do you handle data and the retentions. And for us, we host all the larger model ourselves. So we have a retention policy for all of them. Make sure like their data and all the AI training on their like knowledge going to only used for one client at a time. So those data was never going to share across different providers or patient or provider or business. So that's one thing that's super important to them. Then the second is how do you handle all the really PIIs information in our systems. So those the SOC 2 and the HIPAA are the mandatory for you to operate in the space. I think this is a really good starting point. Then beyond that is how do you make sure all your solution providers, no matter it's speech to text, text to speech, all the service vendors providing service also are SOC 2 compliance and HIPAA compliance. So those are also another important part for everyone who work with us. Make sure everyone who else you interact with also HIPAA compliance. Then third is how for the government agencies, they might come in. Well, hopefully, and things going to change. So if there's anything going to be leakage, make sure all the system you have is up to date with all the security standards. Make sure there's no bug. Not make sure no bug. There's every security issues have been patched. So stay updated with all the security issues you may encounter. Those are the things we make sure we follow.
Yeah, no, it's a lot, especially in the American context. Maybe a little bit different in different countries, but I'd imagine quite a lot to handle. Another question that we have is from Kofo here is, do you have are you fully integrated into the EHR systems directly, or is that sort of something that you lay on top of when you're making these calls?
Yes. So right now we are lay on top of EHRs. We don't work with EHR directly right now since we show proof of work. So so we rely on our customers right now to work with us since we're more like the AI call centers. We work on your behalf of making those calls, but we don't directly integrate with the system yet.
Yeah, no, that's great. So we've heard a little bit about earlier in the conference today. We've heard a little bit about perspectives on performance of these agents. When they get out into the real world and they're being compared to benchmarks, whether they're sort of academic benchmarks or real world benchmarks like services, customer service numbers like you were showing earlier.
Yes.
Your numbers are quite positive, which is really incredible. One question that we have here is, in terms of customers and businesses using this technology, do you find that they're mostly are they looking for performance better than their current solution, which is folks making these calls going by different SOPs, or are they more concerned with not underperforming the worst performers in their current solution? Do you know what I mean? There's sort of two ways to measure your threshold there.
Yeah.
Are you trying to get better, or are you trying to not be worse? What do you find in the market?
Yes. So I think all our customers started with concerning, okay, can AI actually outperform a human in those phone calls? But we see our results as showing them we are much better than humans in those phone calls, and we're much more efficient. And I think there's two level of metrics, but larger model do make some simple and stupid mistakes. So but how do you prevent those, catch those in during the phone calls? And that's a harder part. But for us, we have showing to our customers with the right technology how you can handle those calls, even jumping the calls, you can make the AI actually much better than human in a similar situation. One example we can show, for some of the claims, for humans usually take probably 2 to 3 phone calls for them to actually find the right reason to why they get denied. But for us, only we take up 1 to 2 calls. Our AI can actually negotiate with the human and push back on the human representative to get the actual result. And it's actually outperform human in a lot of scenarios.
Cool. Great. Well, thank you so much, Shaun. I think that's all the time that we have for now. Really appreciate you coming in and sharing your thoughts here, and hope to see you soon.